Hi students, this chapter we will be looking at acids, alkalis and bases and the pH indicators. Okay, so acids and alkali, they are very common reagents that you will be using in the school laboratory. Okay, so essentially they look just like colorless liquid. They look just like water, but of course they are not water. There are certain special properties that make it an acid or an alkali. So we will be looking at these properties, exactly what they are. Okay, so we have the definition of acids over here. Acids have H plus in them. Acids dissociate to give hydrogen ions in water. Dissociate really just means it is soluble or it dissolves. Some schools use the term ionize. Okay, so it means the same thing. Okay, so let's look at some examples of the acids over here. Okay, we have hydrochloric acid, HCl. Hydro comes from the hydrogen, which is H plus ions, and then chloric comes from chlorine, so you get your chloride ions. Okay, nitric acid, HNO3. HNO3 actually come from, again, your H plus ions, the hydrogen ions, and then recall your polyatomic ions, nitrate. Okay, and then we have your sulfuric acid, H2SO4. Okay, we have the H plus ions and your SO4, 2 minus ions. Okay, if you can remember this, how do we get your H2SO4? We write down the ions. Okay, and then we do the cross multiply method. So I bring the 2 down, you get H2SO4. 1, you bring it down, you don't need to write. That's why your formula is H2SO4. Okay, so if you look at all these acids, they are essentially covalent compound because this is non-metal bond to non-metal. Non-metal, non-metal, non-metal. So they share electrons. Okay, we use the most simplest example, your hydrochloric acid. It will look like this in your chemical bonding. Okay, so covalent compounds, they are not soluble in water, okay, but now that it is an acid and it has hydrogen ions, right, this actually made it very special. So this type of covalent compound or this acid will be soluble in water. So what happens, this HCl gas over here, your hydrogen chloride gas, okay, if I have a beaker of water, right, and then I bubble this hydrogen chloride gas through the beaker of water, it will dissociate or it will ionize to form H plus and Cl minus. So it will separate out, it will dissolve. Okay, and then after that, right, this whole thing, it becomes your HCl acid, your hydrochloric acid. Okay, so this is the definition. Acids dissociate to give hydrogen ions in water. And once we have these hydrogen ions, this will give the properties of your acid. So properties of acid, they are corrosive and sour. So corrosive, okay, next, the second part or the later part of the lessons, we will learn about the chemical reactions. You will learn that acids can also react with metal, making it very corrosive. Okay, acids, they taste sour. Right, very common examples of acid that's found in daily life will be found inside your citrus fruits. So citrus fruits is your citric acid. Okay, it's the presence of citric acid in the citrus fruits, for example your oranges, lemon, that make the fruits sour. Okay, apart from that, another common example of an acid will be your ethanoic acid. Okay, ethanoic acid is found in vinegar. So vinegar, if you have tasted before, it will also be sour. Okay, acids are good conductors of electricity in water. Okay, because when you dissolve it in water over here, the ions will separate out. So when the ions dissociate or when it ionizes, right, the H plus and your Cl minus, they act as charge carriers to conduct electricity. Okay, and then the last one is it turns your moist blue litmus paper red. So I remember it as blue turn red, right? Because red is dangerous, it is corrosive. So acids will turn the moist blue litmus paper red. Okay, your blue litmus paper will really just look something like this, a piece of paper, and then the whole paper is blue in color. Okay, but then there is definitely some chemical properties that made it a litmus paper. So if you have this blue litmus paper over here, and then you have a beaker of colorless solution. Okay, so you put your blue litmus paper inside and then you take it out, it will turn red. Once it turns red, this one must be an acid. Only the acid will turn the blue litmus paper red. Okay, next thing that we are going to look at, the strength of your acids, right? Strength of the acid. So the strength of an acid depends on its extent of dissociation in water, or how much does it ionize, or how much does it separate in water. Okay, so we have what we call the strong acid. Strong acid will dissociate fully to produce a large amount of hydrogen ions. Okay, what does this mean essentially is, for example, if I have a beaker of water, right, I put 10 HCl, I bubble 10 HCl inside. All 10 will separate into H plus and Cl minus. Okay, all of them separate. This is dissociate fully or complete dissociation. And then it will be a strong acid. Yeah, weak acid dissociate partially to give low hydrogen ions. Okay, so in the same example, okay, I have a beaker of water, and then now I have a weak acid over here, CH3COOH. Okay, this is a very common example of the weak acid, which is over here. It's called ethanoic acid. Okay, if I have 10 CH3COOH, I put it inside water. Okay, at any point of time, only 5 will separate into H plus and 5 CH3COO minus. Okay, the other 5 will remain as molecule. Okay, this idea over here means that they dissociate partially, and then because I will only have 5 H plus, this give me low concentration of hydrogen ions. A lot of them, they remain as molecules in water. Okay, so important idea over here is we must know the common examples of your weak acid. Right over here, your common examples of your weak acid. The most common one they will give you is your ethanoic acid, CH3COOH. Okay, so let's look at this ethanoic acid a little bit more in detail. Yeah. Okay, ethanoic acid will look something like this. If it's a covalent bond, your carbon, there's 4 outer electrons, it can form 4 bonds. So there's 4 lines coming out from each carbon. Okay, each of these first carbon is connected to 3 hydrogen, so CH3, and then you have another C, and then you have O. Oxygen can form 2 bonds, so 2 lines coming out, and then connected to OH. So this structure is your ethanoic acid. Okay, so which H will dissociate to give you hydrogen ions in water? Okay, it is not this one, it's not this one, it's not this one. Please know, ultimate important is this last H that separate into H plus. Okay, so the whole thing over here, this whole thing will have a minus charge, and that's why I have CH3COO minus and H plus. Okay, dilute strong acids contain large amount of water, all the molecules will dissociate. Okay, so I just want to let you all know the difference between dilute and strong and weak acid. Okay, dilute just means I have a lot of water and then very little molecules. So for example, if I have a 1000 cm3 H2O, the water, and then I try to dissolve 10 molecules HCl, right? This one will be a dilute strong acid, right? Because my HCl, all 10 will separate, but I dissolve it a lot of water. okay? Conversely, I can have a concentrated strong acid. So if I still have 1000 cm cube of water, okay, but instead of 10 molecules, now I have 1000 molecules also of HCl. Okay, all these 1000, it will separate into 1000 H plus and 1000 Cl minus. Okay, but in this case now, your water to HCl ratio is much lower. Okay, so this is what we call a concentrated strong acid.